One river can become a choke point without a navy, a border crisis, or a single dramatic blockade. On the Rhine, the decisive signal can be a number on a gauge near Kobe, where water depth helps determine how much cargo a barge can hold. If the level drops, the river doesn't vanish from the map. It holds flowing, towns remain on its banks, and barges may still move. But the capacity of the corridor shifts, and the economy built around that corridor has to adjust. This is why the Rhine is one of Europe's most revealing infrastructure choke points. It reveals how a route can fail by becoming shallow rather than closed. That river connects North Sea ports with industrial regions inland. Chemicals, fuels, construction materials, grains, metals, and industrial inputs use the corridor because water transport can move heavy goods efficiently. A barge that carries large volumes at normal depth becomes less useful when it has to sail only partly loaded. That vessel is still present, the route is still present, and the demand is still present. What disappears is holding efficiency. That small physical shift can produce a large economic signal. The first channel is load reduction. If water levels are low, vessels lower cargo to avoid grounding or unsafe navigation. This means the same amount of goods may require more voyages, more barges, or alternate transport. The river's capacity drops without a gate being shut. The second channel is freight cost. If a ship can hold less, the cost per ton rises. Traders and industrial firms may pay surcharges, split cargoes, or move goods by rail and truck at higher cost. That transport system becomes less efficient precisely when companies need reliability. The third channel is substitution pressure. Rail lines and roads can help, but they aren't infinite backups. They have their own capacity limits, labor constraints, scheduling problems, and infrastructure bottlenecks. One low river, therefore, pushes stress into other networks rather than removing it. That is the part of the Rhine story that matters beyond Germany. Europe often talks about energy security, industrial competitiveness, and supply chain resilience as separate themes. The Rhine connects them in one physical corridor. If fuel cargoes, chemical inputs, coal, agricultural products, or industrial materials move more slowly, the effect can show up inside production planning. A factory doesn't need the river to be completely blocked before it begins to feel exposed. It only needs enough uncertainty in delivery cost and timing to shift decisions. That river also teaches a lesson about climate and infrastructure. Low water isn't a one-time event that can be treated only as bad luck. Repeated drought periods, heat waves, and altered rainfall patterns make waterway reliability a strategic question. One route that was once assumed to be stable becomes variable. This variability is hard for industries built around predictable logistics. The Rhine's importance comes from habit as much as geography. Companies locate storage, terminals, pipelines, rail connections, and production schedules around expected river performance. If the river underperforms, those expectations are exposed. The system has to then choose between paying more, waiting longer, shifting modes, or holding more inventory in advance. Each option costs money. That quiet danger is that firms may normalize the cost rather than solve the vulnerability. When low water surcharges become a recurring seasonal feature, the river remains valuable but less dependable. That can shift investment decisions over time. New storage tanks, different sourcing, shallow draft vessels, rail upgrades, or shifted production buffers can all get pulled into adaptation. The Rhine therefore becomes a long-term planning issue, not just a weather story. It also reveals why inland choke points receive less public attention than maritime ones. One tanker in a strait is easy to visualize. One depth gauge in a river is less dramatic. But the depth gauge can affect thousands of tons of cargo and many factories that never appear in the footage. The spectacle is smaller, but the consequence can be broad. That is why Kobe appears again and again in market reports. It isn't because one town controls Europe. It is because that measurement point helps reveal how much useful capacity remains in a key industrial corridor. If the number drops, market participants translate water depth into cargo limits and price. This translation is the mechanism. The river's strategic value also sits inside its geography. It links the port of Rotterdam and other North Sea access points to inland demand centers. It passes through a dense industrial landscape where water transport isn't a luxury. For bulky commodities, A barge is more than one option among many. This is often the most efficient option under normal conditions. If normal conditions fail, the alternatives can be slower, more expensive, or already busy. This is how a climate signal becomes an industrial signal. One dry spell becomes a cargo limit. One cargo limit becomes a freight surcharge. One freight surcharge becomes a production cost. One production cost becomes a competitiveness question. The chain isn't dramatic, but it is powerful. That policy response is also more complicated than simply telling the market to adapt. Dredging, river engineering, vessel redesign, forecasting systems, storage planning, and rail capacity all involve cost and trade-offs. Too much engineering can produce environmental concerns. Too little adaptation leaves industry exposed. A serious solution has to respect the river as both an economic artery and a living water system. This tension makes the Rhine a modern choke point in the fullest sense. It is more than narrow water. It is a place where industry, climate, logistics, ecology, and state planning meet. That route works when enough water, infrastructure, vessels, and contracts align. It becomes vulnerable when one of those elements drops below the level the system assumed. For viewers used to thinking of choke points as straits, the Rhine offers a different lesson. Power can sit in depth, not just width. A few centimeters of water can decide if a vessel holds a full load, a partial load, or waits. This decision can ripple through fuel markets, chemical supply chains, and manufacturing plants. The river remains open, but the economics of using it shift. This is why the Rhine should be understood as a corridor of conditional capacity. Its strength is enormous under normal water. This Rhine's vulnerability becomes clearer if we treat the river as a machine rather than scenery. That machine has moving parts, water depth, locks, terminals, barges, crews, warehouses, rail connections, industrial demand, and weather forecasts. If water levels drop, one gear in the machine slows down, and the rest has to compensate. One barge that once carried a full cargo may now sail light. Another vessel may require to take the remaining load. A rail operator may receive a request it can't immediately absorb. One factory manager may check storage levels more often than usual. That corridor still works, but it works with a penalty. This penalty is where the choke point hides. One maritime strait often feels binary to the public, open or closed. This Rhine is more graduated. It may be open at reduced capacity, expensive at partial capacity, and strategically painful without ever becoming invisible on a navigation chart. This makes it harder to communicate, but not less important. Industrial systems dislike uncertainty because they are built around sequencing. A chemical plant may require feedstock at the right moment. A fuel distributor may require deliveries before demand peaks. A steel or construction supply chain may require heavy inputs in volumes that trucks can't easily replace. If barge capacity drops, the issue isn't only whether something can arrive eventually. That issue is whether it arrives at the scale, price, and timing that the production system expects. That river also reveals a hidden dependence on cheap heaviness. Water transport is valuable because it moves bulky goods with efficiency that roads and rail may struggle to match. If the river loses capacity, the economy is pushed toward more expensive modes for exactly the cargoes that benefit most from water movement. That is why the shock can feel larger than the public expects. One few centimeters at a measuring point can translate into many tons not loaded onto a vessel. This missing cargo has to be delayed, divided, or rerouted. Each choice adds cost somewhere. A logistics manager may accept a surcharge to hold a customer supplied. One trader may adjust a contract. One plant may use inventory that was meant as a buffer. Buffers are useful, but they aren't infinite. Repeated low water episodes can make companies ask whether the old buffer assumptions still fit the climate they face. That is when a temporary river issue becomes a strategic investment question. Do firms build more storage? Do they redesign procurement calendars? Do they support shallow draft vessel fleets? Do governments deepen channels, improve forecasting, or invest in rail alternatives? None of these choices is free. They all reveal how much Europe is willing to pay for resilience in a corridor that used to be trusted more cheaply. That Rhine is especially important because it sits inside an advanced economy, not outside it. This isn't a remote route serving a single commodity. It runs through one of Europe's densest industrial landscapes. This makes the river both efficient and exposed. Efficiency concentrates activity around the corridor. Exposure appears when the corridor's natural conditions shift. That climate dimension adds a long-term warning. One single dry period can be managed as disruption. A pattern of dry periods begins to shift planning assumptions. If companies expect low water more often, they may shift contracts before the next drought arrives. When insurers, traders, and transport firms expect seasonal vulnerability, prices may begin to include that expectation. That physical river then shapes financial behavior even in months when water looks acceptable. This is a subtle form of leverage. Nature doesn't negotiate, but it can still force the economy to pay attention. The river's administrative environment matters too. Cross-border corridors require forecasting, maintenance, port coordination, and communication across different jurisdictions and industries. One low-water event tests whether those institutions can give clear guidance quickly. Uncertainty about restrictions can be almost as costly as the restriction itself. Companies can plan for a known limit. They struggle with a limit that shifts faster than contracts, and transport slots can adjust. That is why data becomes part of infrastructure. One reliable gauge, a forecast model, and a transparent warning system help the market adapt with less panic. They can't create water, but they can reduce the cost of surprise. The Rhine also shows that resilience isn't always about building a new route. Sometimes it means making an old route more flexible. This could involve vessel design, smarter loading practices, better terminal coordination, more storage near critical plants, or contracts that anticipate low water surcharges. These aren't spectacular solutions, but they are the kind of details that keep an industrial corridor from turning into a recurring emergency. For policymakers, the danger is treating low water as a seasonal nuisance rather than a strategic signal. When a key corridor repeatedly operates below normal capacity, the effect is cumulative. Companies may invest elsewhere. Production costs may climb. Supply chains may hold more inventory. Transport emissions may grow if cargo shifts to less efficient modes. A river level can therefore influence competitiveness in ways that don't appear in a single day's headline. That is why the Rhine belongs in a Chokepoint Ledger. It demonstrates that strategic pressure can come from hydrology, not only from hostile intent. The pressure has no flag, no slogan, and no commander. It passes through depth, tonnage, prices, and missed efficiency. This makes it less dramatic but more persistent. A society that plans only for deliberate disruption may miss the infrastructure stress created by physical shift. This Rhine asks Europe to think differently about security. Industrial security includes the ability to hold heavy goods moving when rivers run low. Energy security includes the routes that move fuels and inputs inland. Climate adaptation includes the transport corridors that were designed around older assumptions. Those themes meet in the water below a barge. If that water drops, the river explains how close the economy remains to physical geography. The Rhine also shifts the way companies think about inventory. If transport is stable, lean inventory can look efficient. If water depth becomes unreliable, the same lean system can look exposed. One firm may decide to hold more material near a plant, even though storage ties up money and space. Another firm may sign flexible transport contracts, paying more for the right to switch modes when water levels drop. One third may redesign delivery schedules around seasonal risk, accepting that summer or drought months require more planning. These decisions aren't emergency responses anymore. They are structural adaptations to a river whose reliability is being reevaluated. That political challenge is that adaptation costs are dispersed. One company pays for storage. Another pays for rail capacity. One public authority pays for forecasting or infrastructure. Customers may pay through prices. Since the costs are spread out, the strategic meaning of the river can be underestimated. No single invoice says that Europe has a river choke point problem. Instead, the evidence appears across freight rates, production warnings, waterway notices, and investment decisions. This dispersed evidence is exactly why the corridor needs serious attention. It also matters that low water can coincide with energy stress. Periods of heat and drought can lift cooling and power concerns while also limiting transport capacity. This means the same weather pattern can pressure both demand and supply logistics. One fuel cargo delayed by low river levels arrives in a market that may already be anxious. One chemical input held back by reduced barge loads can affect a plant already facing energy cost concerns. That river becomes a multiplier. It doesn't produce every industrial problem, but it can worsen problems that already exist. That multiplier effect is what makes a depth gauge strategically important. It condenses weather, industry, transport, and cost into a single visible measure. If that measure weakens, the wider system begins calculating how much resilience it really has. That Rhine's lesson is therefore not only European. Any inland corridor dependent on water, snowpack, rainfall, or seasonal predictability can face a similar future. Infrastructure built around old climate assumptions may require new buffers, new vessels, new contracts, and new public investment. The river is more than holding cargo. It is holding a warning about how physical systems age under changing conditions. Another hidden issue is contract memory. After several difficult seasons, firms begin writing low water expectations into agreements, budgets, and contingency plans. This means the river influences behavior even before the next gauge reading becomes alarming. One corridor can therefore lose some of its old certainty gradually, through pricing habits rather than through a single spectacular failure. That river also affects planning psychology. Managers who once treated low water as an occasional disruption may begin treating it as a recurring operating condition. That shifts how they read forecasts, how they negotiate transport, and how much inventory they consider prudent. One choke point becomes more powerful when it shifts behavior before the next disruption arrives. Its weakness appears when the corridor has to carry the same demand with less physical depth. In that moment, Europe sees a simple truth. Infrastructure risk isn't always built from conflict. Sometimes it is built from weather, measurement, and the cost of moving heavy goods through a shallower